Hello everyone, I am Pravina from Second Cybersecurity. My teammate is M. Maunavi from Second Cybersecurity. We made this presentation under the guidance of Dr. M. Prasad, Associate Professor belonging to Department of CSC.
Multithreading model. Multithreading allows the execution of multiple parts of a program at the same time. These parts are known as threads and are lightweight processes available within the process. Multithreading leads to maximum utilization of the CPU by multitasking. Multithreading allows the application to divide its tasks into individual threads. We can say that there is more than one thread to perform the task in multithreading.
In this picture, we can see the difference in process execution with single thread and multiple threads. The main models for multithreading are one-to-one, many-to-one, and many-to-many. Firstly, let us know about one-to-one model. The one-to-one model in operating systems refers to a design where each user level thread corresponds to a single kernel level thread. Here are some of the advantages and disadvantages of this model. Firstly, let us look about the advantages of one-to-one model. First one is parallelism. Each user level thread can be scheduled to run on a separate kernel level thread, enabling true parallel execution on multi-core processes. Second is responsiveness. If one thread blocks, the other threads can continue to execute, ensuring better responsiveness for applications. Next is improved performance. With a one-to-one model, it's easier to exploit the full potential of multi-core CPUs, resulting in better performance for multi-threaded applications. Now let us look about the disadvantages of one-to-one model. First is resource inefficiency. Kernel level threads consume more system resources than lightweight user level threads, which can be a disadvantage in resource constrained environments. Second is overhead. Creating and managing a large number of kernel level threads can introduce significant overhead. Context switching between threads at the kernel level can be costly. Next is limited OS support. Some operating systems may not fully support the one-to-one model, which can limit its adoption. Now, the remaining part of the presentation will be continued by my friend Maunavi.
A many-to-one model in operating system typically refers to a threading model where many user-level threads are mapped to a single kernel-level thread. Here are the advantages and disadvantages of such model. Advantages: simplicity. It's relatively simple to implement since user-level threads are managed entirely in user space without kernel involvement. Efficiency. Context switching between user level threads is fast and efficient because it does not require kernel intervention. Scalability. It can support a large number of threads since user level threads are lightweighted. Disadvantages are lack of parallelism. Since all user level threads are mapped to a single kernel thread, they can take full advantage of multi-core processor. If one thread blocks, it can cause all user level threads to block. Limited responsiveness. If a user level thread making a blocking system call, it will block the entire process, affecting the responsiveness of other threads within the process. Difficulty in utilizing multi-core CPUs. Modern computers often have multiple CPU cores, and the one-to-one model doesn't fully utilize them. This can lead to the underutilization of hardware resources. Many to many. In this model, we have multiple user threads multiplexed to same or lesser number of kernel level threads. Number of kernel level threads are specified to the machine. Advantage of this model is if a user thread is blocked, we can schedule other user threads to other kernel thread. The system doesn't block in if a particular thread is blocked. Here are the advantages. Better utilization of resources. In the MN model, you can have more user level threads than kernel level threads, allowing for efficient utilization of system resources. This means you can have a large number of lightweight threads running on a smaller number of heavyweight kernel threads. Improved responsiveness. By multiplexing user level threads onto a smaller number of kernel threads, the system can remain responsive even if some user level threads block or perform IO operations. This is especially useful in applications that need to handle concurrent IO efficiency. Flexibility. Developers have more control over the thread management in the many-to-many model as they can decide how to map user level thread to kernel level threads. This flexibility can lead to better tailored solution for specific application requirements. Here are the disadvantages. Complexity. Managing and coordinating multiple processes, accessing multiple resources can be complex, leading to the potential synchronization issues, deadlocks, and race conditions, and security concerns. Controlling and enforcing access permission and security in a many-to-many model can be challenging, increasing the risk of unauthorized access and data breaches, limited predictability. The behavior of a system with many-to-many relationship may be less predictable, making it harder to ensure consistent performance and behavior. This is the end of the multiple threads models. And thank you for giving us this opportunity.